system. For things that are far away from the solar system, for stars, okay, what astronomers use is a unit called the parsec. And the parsec uses the parallax method to being able to show where the star is, how far the star is. The way that it works is that astronomers measure the angle or the position of a distant star against the background of much farther distant stars. Okay, so here it shows Ursa Major, all right, and another star that is closer. And so we see that at one point of the year, when the Earth is at this point in the orbit, the star that we are looking at looks to be in this position, okay? Looks to be kind of between the leading edge, you know, within the deeper part of Ursa Major, or the Big Dipper, all right? Now, 6 months after, as the Earth goes around the Sun in its orbit, astronomers look at that same star again and measure the position of that star against the background of the other stars, and they see that now that the star appears to be in a different position. Of course, the star has not moved. What it has moved is actually the Earth and the angle at which we can see the star. And so that is the parallax effect, all right? So the parallax effect is the effect that you see things moving when you change your point of view, your perspective point of view. The object is not moved. What you are seeing is the angle of perspective. And so astronomers measure the angle here of parallax, and then they are able, through trigonometry, to measure the distance between the Sun and the star, okay? So if this angle is 1 arc second, okay, so that would be, 1 degree of an angle has 60 minutes. Each minute has 60 seconds. This is not a measure of time. This is a measure of angles. So if it's a really, really small angle, just 1 second, then the distance for a 1 second parallax is 1 parsec. That is the definition, okay? So let's look at another graphic of the same effect, all right? And so you can see here where the parallax angle is being measured, all right? So if this angle is 1 second, then this distance, the distance between the Earth and the star, is 1 parsec, okay? So 1 parsec is about 206,265 astronomical units. Remember, one astronomical unit is the distance between the Earth and the Sun, okay? So the parsec is enormously, much bigger than the astronomical unit. That is why the parsec is used for measuring distance to the stars, okay? The nearest known star to the Earth, other than the Sun, is called Proxima Centauri, and it is 1.3 parsecs away, all right? So can you see that the parsec is a lot easier to use as a measure of distance than the astronomical unit, okay? Here we would have to say, oh, it is 260 something thousand astronomical units away. So instead of using the astronomical unit, when we talk about distance to stars, okay, to relatively close stars, we use parsecs instead of astronomical units. So you see there another example of how the unit of measure changes depending on what is it that we are trying to measure. A third